Welcome to Unit 3, Lesson 7, Solving Rational Equations. Let's think about how to solve rational equations strategically. Okay, what do you notice? What do you wonder? So what's going on in this situation? We have two denominators over here. One here, one here. When you have two fractions set equal to one another, it's called a proportion. In order to solve proportions, the first thing you need to do is cross multiply, which we see going on in step 2. So if this is step 2, we see that they cross multiplied. And the denominator and the numerator are the same, so they cancel out. On the right side, only the x minus 2 part is the same. The x had to be distributed to the 2x and the 1. And that's how you wind up with line 3. In line 4, you have a quadratic term, which means it's squared. The x is squared plus an x, which means in order to factor it in line 4, you have to set it equal to 0 so that you can factor it. So that's what's going on in this problem. We're not asking you to solve it. We're asking you to notice the steps. So, 1, we cross multiply or butterfly to get rid of the denominators. Anytime you have a denominator, cross multiply. 2, you have to distribute and simplify. And then 3, we solve for x. Now, today is a little different because this is the last lesson, so we're solving strategically. So what is different about today? Okay, let's look at this problem. Jada is working to find values of x that make this equation true. She says if I multiply both sides by x times x plus 1, that's both denominators, I find that the solutions are x equals 1 and x equals negative 1. But when I substitute in x equals negative 1, the equation does not make any sense. So let's look at this strategically. Okay. Now, back in lessons 2 and 3 of this unit, we looked at how to find a vertical asymptote. We set the denominator equal to 0. When x is equal to 0, you have a solution that does not work. So on the right side, x cannot be 0. On the left side, you have x plus 1. Set that equal to 0. This is also the way to find vertical asymptotes. If I subtract 1 from both sides, x cannot be negative 1. When x equals negative 1, the denominator is 0. We cannot divide by 0. So these solutions will not work. If I get a solution where x is 0 and negative 1, that makes this that will make the equation not true, and so they don't work. So yes, Jada is correct. Negative 1 does not work because it makes the denominator 0 on the left. Now, let's solve and see what the actual things are. If we cross multiply, we get x times 5x plus 5. Whenever you have two terms, make sure you put them in parentheses so you know to distribute to everything, because people forget parentheses and they only multiply to one term. But there are two terms here that both must get attention. So we cross multiplied, we distributed, we simplified. Now we have to solve for x, step 3. Now, I like my letters on the left, so I'm going to move the 5x on the right to the left by subtracting it. If there's no sign in front of a number, that number is assumed to be positive, because if it wasn't positive, it would have a negative sign. You get 5x squared. Oh, wait, I forgot to distribute the 5 up here. I'm sorry. Is equal to 5. We divide by 5 on both sides. We get x squared is equal to 1. Now, when we solve an equation, the coefficient, the number out front, must be positive 1. The exponent must be positive 1. We don't have a positive exponent of 1. We got a positive exponent of 2. So in order to solve, we have to take the square root. The opposite of squaring a number is taking a square root. It's like multiplying and division are opposites. Squares and square roots are opposite. When you take the square root of a positive number, you get two answers, one positive and one negative. We already know that the negative solution doesn't work. So the only real solution for this problem is x equals 1. Sometimes when you solve math problems, you get solutions that don't work. That just happens. They work mathematically, but they don't work out in real life. And we're going to talk about that in the next unit. Okay, now let's look at the next set of problems. Here are a lot of equations. For each one, use what you know about division to identify values of x that cannot be solutions to the equation. All right, so we're going to start with A. Okay, if I set the denominator equal to 0, I get x minus 2 equal to 0. If I add 2 to both sides, x equals 2 does not work. It is not a solution. You can find x equal to 2, but if you get x equals 2, it doesn't work because it makes the denominator 0. Okay, so that's all we have to do for these. For B, which is going to be in orange, if I set x equal to 0 on the left, I know on the right side, x equals 2 doesn't work. So these two numbers, if they become solutions after I do everything, they don't work. And we don't even have to go through the trouble of solving it. Okay, for C, which is going to be in purple, my solutions cannot be x plus 8 equals 0, x minus 8 equals 0, subtract 8, plus 8, plus 8. X cannot be negative 8. X cannot be positive 8. It cannot be. Negative 8 and positive 8 will make the denominator 0. It can be anything but those two numbers. And then for D, which is going to be in red, x minus 1 equals 0. Add 1 to both sides. The only solution that does not work is x equals 1 because we know that cannot be solutions. These numbers cannot be solutions. We don't even have to go through the trouble of solving for it. Okay, for E, x cannot be 0. 0. If we get 0, it doesn't work. For F, x cannot be 0. And then we take this side, we separate it to x equals 0 and x plus 1 equal to 0. Subtract 1 on both sides. X cannot be negative 1. So if we get negative 1 and or 0, these are not solutions. Orange, same thing as the previous page. X cannot be 0. X cannot be 2. Cannot be. If you get these solutions, it doesn't work. For H, I'm going to take this one because this has x minus 3. The left side has x minus 3. The right side has x equals 0 and x minus 3. So x cannot be 3. It cannot be 0. And for the last one, F, I, H-I, I'm sorry. X plus 1 equal to 0. When I subtract 1, x cannot be negative 1 because negative 1 makes the denominator 0. So it doesn't really matter what I do. I can't use these solutions. Now, I'm not going to solve them because that's not what the instructions asked us to do. We should know how to cross multiply and distribute and all that. Thank you for watching this video. This is the final lesson of Unit 3. And this is the end. Yay.